Hello friends, this video on application of derivative part 26 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 25. Let's take one more question. We have to find the sum of two numbers whose sum is 24 and the product is as large as possible. Again, the first question, is it the absolute global maxima question? Let's see. The question says x plus y be a two number, the sum is 24 and xy is some maximum number. But here if you see there is no domain, no interval, nothing. So since the interval is not defined, it's an open interval question, so it is not a absolute maxima question. Correct? Now if you see x plus y is equal to 24 and xy is equal to max, we have to find the value of, what is find? We have to find these two numbers. The thing here is we are told that x into y is max. And let me write everything in the one form. If I say xy, instead of y I will say 24 minus x. So I can say that x into 24 minus x is equal to some maximum value. Correct? Or to rephrase, I have to find maximum value of x into 24 minus x or 24x minus x. So can we find this? Yes. So what I have done, I have rephrased this question. The question says there are two numbers x plus y, that is 24, and x into y into maximum is equal to maximum. X into y is nothing but x into 24 minus x. That means I have to find a maximum value of this function. If you can find the maximum value of this, I can find the value of x at which it is maximum. Correct? So I have to find the maximum value of x at which this is maximum. If I have the value of x at which it is maximum, I can find the value of y. If I have x and y, that means I have the number. See, just I rephrased this question in a mathematical term. X plus y 24, xy is equal to max. So I wrote x into 24 minus x is equal to max. That means I have to find the value of x such that this function is maximum. Correct? And this kind of question we have done. We have to find the value of x for which the function is maximum. So here also before finding the value of x, I have to find the critical points. So critical points can be here endpoints, then my non-differentiable and turning points. Endpoints not in picture because it is an open interval thing. Continuous function, non-differentiable, not in picture. So the only thing is turning point. So if my fx is equal to 24x minus x square, I have to find the value of f dash x and make it 0. So f dash x is nothing but 24 minus 2x, and this guy has to be 0. So x is equal to 12 is my turning point. Now I have to check whether at x is equal to 12 this function is maxima or minima or inflection. Correct? So to double check, because I have to check, so let's find f double dash x. Will be nothing but 24 becomes 0, minus 2x become minus 2, and f double dash of 12 is nothing but minus 2, and that is less than 0. Since it is less than 0, I can say that the maxima at x is equal to, so x is equal to 12, this function will attain the maximum value. So I can say my x is equal to 12. So y is nothing but 24 minus x, 24 minus x, and that is 12. So x is equal to 12 and y is equal to 12 is my answer. So if you see, x plus y is equal to 24 here and x into y is equal to 144. So this is how we solve this. And the general rule is, if you have number n, you want to divide in such a way that the product is maxima, you just split into 2 equal half, n by 2, n by 2. So in this case, the product of these will be maximum. That's the general rule. So if you get such question exam, then you can just see if the answer you are getting is n by 2 or not. Here n by n is 24. So these are 12, 12, 24 by 2 and 24 by 2. How we found this? We converted this statement into mathematical representation. X plus y is equal to 24, where x and y are two numbers and x, y is maximum. Instead of y, I wrote in terms of x. I got an equation and I wanted to find the value of x for which this equation is maximum. I got the value of x. I want to double check that. So I double differentiated this. I confirmed here now that this x equal to 12 is the maximum. The point at which this function will have the maximum value. And then I got the value of y also. And x and y came out to be 2. Let's take one more example. We need to find two positive numbers whose sum is 12 and whose cube is minimum. Here also, if you see, it is not the absolute maximum and minimum quotient. Why? Because if x and y are two positive numbers, what we are saying is x plus y is 16. Sum of two numbers is 16. And sum of whose cubes is minimum. That is, I'm talking about x cube plus y cube is minimum value. Similar approach we'll do. Instead of y, I'll say, or with this, if you say y is nothing but 16 minus x, this becomes x cube plus 16 minus x cube has to have a minimum value. So let's assume I have a function. That function is nothing but x cube plus 16 minus x squared. I have to find value of x for which fx is minimum. Correct? So for this, if you see here again, same thing. It can be endpoint, it can be non-differentiable point, or it can be turning point. Endpoint not possible because the open interval thing. Non-differentiable not possible because it's a continuous function. The only point is continuous point. Turning point. For turning point, f dash x is equal to 0. So let's find f dash x. F dash x becomes x cube become 3x square. 16 minus x cube become 3 into 16 minus x square into minus 1. Correct? This is f dash x and this is equal to 0. So if you solve this equation, so this becomes nothing but 3 into x square minus 16 minus x square. I can expand or let it be like this only. Correct? Or this is nothing but 3 into x minus 16 minus x into x plus 16 minus x. This guy gets cancelled, is equal to 0. So what I get is 48 into, this becomes plus actually, 2x minus 16 is equal to 0. If you solve this, you get x is equal to 8. So x is equal to 8 is my critical point. Now I have to check whether at x is equal to 8 the function is maximum or minimum. To do this, let's find f double dash x. So this will be nothing but, if you take this guy, it will be nothing but x square will become 2x. Or you take this equation only. This is the one actually, f dash x. So this will be nothing but 48 into 2x becomes 2 and minus 16 becomes 0. That is nothing but 56. So if you see f double dash x is 56, f double dash 8 will also be 56, that is greater than 0. So my x is equal to 8 is point of minimum. Correct? Point of minimum. Since x is equal to 8 now, my y is nothing but 16 minus x, and that is also equal to 8. So my x and y are 8 and 8. So two numbers which I get is 8 and 8, and such that x cube plus y cube is a minimum value. Same thing, same approach, just a different question, same concept. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.